Motion concept number 8.4, graphical representation of motion. We can represent motion in graphically. Motion in graphically. Graphs are very useful tool to understand the information. So in your lower classes, you might have the knowledge how to draw a line graphs, pie chart and bar graphs. Here, we will represent motion in terms of the graphs. So, in the graph, we are having two things, x-axis and y-axis. To represent motion also, we will draw with respect to distance time graph or velocity time graph. So, to understand much more about motion, the graphical representation helps us more. Let's see an example. What is the use of the graph? So here I have taken a latest of COVID raising in a particular city. Now by seeing this graph, we can easily understand certain information. First of all, what is the graph shows at here on this line? So this in the graphical notation we are called as x-axis. So the days from May to June, which is plotted 6, 7, 8 and up to June 1 and 2. And this vertical line in the graph we known as y-axis. So the y-axis shows the number of cases. Now from May 6 the cases are 104. Now you see the line is increasing. It means the number of cases are increasing. Up to 27th of May the cases are increasing very slow. But you see after 27 to 31st the line is increasing very fast. It means it is increasing rapidly. So here the number of cases also mentioning, so the number is more. So here we don't want what is this number matters and all, we want only what this graph tells us. By seeing this graph we can easily understand that from May to June, May 6th to June 2nd, the number of cases are increasing. So that is the importance of the easiest way represent to understand the information. Second, see one more graph at here. So this graph as plotted for different countries. Now this is the country Spain. Now we can see this line is the before the lockdown and this line is after the lockdown. The Spain cases are increased in the lockdown and again the cases are the decreased in the lockdown. So the graph shows it is increased up to there, then again it is decreased up to there. Now if you can take some other country, so here you can take Italy. So Italy also the graph initially during the lockdown, so it is increased up to here and after the graph is falling like this, so it is decreased. So by seeing this shape we can understand it is increasing and again it is decreasing. But when it comes to India lockdown, you can see this shape. So here it is the lockdown and during the lockdown the cases are going like this up to here. Now you might notice a very huge difference from this shape to this shape. Here in Spain, the graph went up to like this. It means it is increased and again it is decreased. But in India, the graph is going like this. So, what do you think? Yes, it's exactly. The cases are not decreasing, still, the cases are increasing. So here we don't bother about the cases. Here we need only the information what we are understanding from the graph. So that is the easiest way to analyze huge amount of information in small graph. So I will discuss the same type of the graphs which related to motion. First I would like to discuss the motion graphs of the distance time graph. So this is the table which I have taken from the NCERT table 8.1. First I would like to plot the distance time graph. So the distance time graph for this. So to plot a graph I need x and y axis. So I will draw an x and y axis. So this is my x and y axis coordinate system. In this x and y axis, we always take on x axis time in seconds. On y axis, we can take distance we can take in terms of meter. So that's why this is known as distance time graph. Distance time graph. Now try to plot this graph by using this information. So where these are meeting, so you can just name it. This is calling as x-axis and this is y-axis. Where they interacting, this is known as origin. And one each interval here I can take. This is the first one. You take as 9:30 a.m. The next one 9:40 a.m. Sorry, it's a 45. 9:45. Then after 10 a.m. Then after 10:15 a.m. Then after 10:30. After that 10:45. Finally 11 a.m. This is the x-axis. What the information is given, we will take that in the x-axis. On the y-axis, which is given as 10, 20, 30, 40, 50, 60 and 70. Now you can represent the corresponding points at here. Now what this information says, at 9:30 the distance traveled by A in meters. So 9:30 the distance traveled by A in meters, it is 10 meters. So this interacting point you can put mark as that corresponding points. So this is the marker point. And at 9:45 a.m. the distance traveled by A in 20. So 9:45. So you can connect these two, 9:45 and 20. Similarly, you can connect at 10 o'clock, it is 30. It's here 10. So it will give the 30. And 10:15, it's 40. It's 10:15. Here it is 40. And 10:30 it is 50, and 10:45 it's 60, and 11 it's 70. Now if we join these all points, if we join these all points from the origin, if you join these all points from the origin, now this is representing a perfect straight line. It is representing a perfect straight line. Now, what this line tells? This line tells about that the motion of the object is uniform. Since it is straight line, so it's a straight line. The straight line tells about the motion of the object is a straight line. So the motion of an object motion is uniform. So in the earlier of this chapter, we discussed motion two types. One is uniform motion, another one is non-uniform motion. According to uniform motion definition, an object covers equal distances in equal intervals of time. So here time interval is 15 minutes everywhere. The distance he covered is 10 meters. So everywhere. So this information already says about the object motion is uniform motion, but if we draw with that help of the information a graph, so the graph, the straight line represents the motion of an object is uniform motion. So this is the NCERT graph which is given. So the distance time graph, an object moving with uniform speed, which represents this straight line. So the straight line motion represents the object is moving with uniform speed. Okay, what else we can calculate from this graph? By using this graph, what we can calculate or what we can measure? So from the graph, we can measure velocity. So you remember the formula, velocity equal to distance upon time. Velocity equal to distance upon time. So we will measure by using this graph. By using this graph, we can easily measure the velocity of moving object. How we can measure? For that, first you remember this formula, velocity equal to distance upon time. Okay. So from graph, to measure the distance, you select any 2 points from the graph. So I would like to select, so this is the point from here to this is the point, and I will select one more point along y-axis. So that is the corresponding point at here. Okay. So for namesake, so this I can call as S1 and this I can call as S2, since S we will give for the distance. and we will select the corresponding the point on the x-axis also, and the same corresponding point on the x-axis. So this is the one, this I can call as t1, and the same corresponding point at here we can call as t2, you can call as t2. Okay, now the velocity v equal to distance. So here the distance between these 2 points, or in another manner I can write this formula as s2 minus s1 by t2 minus t1. So this is the formula to calculate the velocity from the graph. Okay, you can substitute the values s2 what you have taken it here, s2 here equal to 60 meter minus s1 at here 30 meter, so here 30 meter by time. So here the t1, here the t2, the time at here 10:45 am minus 10 am, t2 equal to 10:45 am minus t1 equal to 10 am. 10 am. So if we can do the further calculation at there, so velocity v equal to 60 minus 30, it means 30 meter divided by 10:45 minus 10, it means you will get 45 minutes. You can convert that in terms of second. 30 meters divided by 45 times 1 minute equals to 60 seconds. You can cut 1362 times, so equal to 1 over 90. So 1 over 90 meter per second. So from the graph we can calculate the velocity. So the velocity v equal to 1 by 90 meter per second is the velocity which I calculated from the graph. So we can get certain information from the graph by seeing its shape. If the distance time graph represents a straight line which is passing, so that motion is known as uniform motion. Okay, from the graph what else we can calculate? From the graph we can easily calculate the velocity of the moving object. So that is the information from the graph we can get it. So this is the first graph we are known as distance time graph for the uniform motion.